All right, guys, if you will, today for your table of contents, whatever page you are following on, mine is on 59, if you will put exponential functions. So we've talked about all the exponent rules and how to solve it. Well, now you're going to see an actual graph of one. So once you have that, if you will flip over to your page, and if you want to pause and write that for me really quick, you also have this page right here. And if you would like to, you can go ahead and trim that out. And I wouldn't glue it in yet. I'll show you how to glue it in at the end. So while you pause and write that, I'm going to go ahead and get started. For when you unpause, you can have it all. Okay, for exponential functions, the equation for an exponential function is y equals ab to the x. So we've seen x's before, like we're used to y equals mx plus b, but in an exponential equation, that just means that the exponent is in the exponent spot. And so this b right here, this number that you're going to get in your equation, if it is greater than 1, then the function is what we call exponential growth. And that means it is increasing. Okay, if b is less than 1, then this stands for exponential decay. And that means that the graph is decreasing. Okay, an asymptote, this is a new word for y'all. Y'all probably never heard this one. An asymptote happens when we're talking about exponential, because as you graph these lines are going to make a certain shape in a graph, and it's going to look like the line flattens, and it technically will flatten out, but it never completely flattens. So there's a spot where the graph stops at, and it doesn't cross. So an asymptote is the line where the graph gets close but never touches or crosses that specific line. Okay, so excuse me, you're going to have your calculator for this one because all of your problems are graphing, so we're going back to graphing. So first thing we're going to do is we're going to tell if each graph is growth and decay. Now you can figure out if it's growth or decay by looking at the graph or by looking at the equation. So do you remember how I gave you ab to the x? Well, the b is the number that the exponent's on. So if you look at y equals 2x, there's your exponent, there's your x, and it's an exponential spot, and it's on a 2. Is 2 greater than 1 or less than 1? Since 2 is greater than 1, then we call this exponential growth. But another way for you to figure that out would be if you go to your table, go to y equals, and if you type in 2 to the x. Okay, you're going to hit second graph because I want you to make a table. Let me set my table set back to where I should be starting. Okay, you should be starting around 0. Okay, so what we're going to do is we're going to look for some points that are kind of easy to plot. Okay, so we're going to start, I'm going to start you with -2. So I'm going to come over here, I'm going to make a little table. This is my x, this is my y. I'm going to say we have -2 and 0.25, -1 and 0.5. We have 0 and 1, 2 and 4, 3 and 8, and I can't plot 4 and 16 because my graph doesn't go up to 16. So I'm looking for numbers I can plot. Okay, so now that I know this is growth, I'm going to start at -2 and at about 0.25, which would be somewhere right there. Then I'm going to do -1.5. Then I'm going to do 0, 1. We're going to do 2, 4. We're going to do 3, 8. Okay, now that you have these points, I want you to graph this so you can see. If you notice as it's graphing this blue line, it looks like it's touching and then it starts curving up. Do you notice how this blue line never crosses right here? So when you draw your graph, I need to make sure that you do the exact same thing. You're going to draw your points going up and that the graph keeps going forever. And then you're going to draw and that this line starts flattening right here. Okay. The domain, y'all have done domain and range. Domain, remember, is x. So how far left and how far right does it go? Well, this graph goes forever to the left and it keeps forever to the right. So your domain is all real numbers. Now your range, this graph does not go down forever, but it does go up forever. So you have to figure where it stops going down. And the graph never goes any lower than right here. Okay, that line is at 0 on the y-axis. So we're going to put y and we're going to put 0. Now, this line is also your asymptote. So we're going to put y equals 0. Whatever your range is happens to be your asymptote. So now the only thing is your range gets inequality because it does go up forever. You need a greater than symbol. And this one does not get an equals bar because if you remember, an asymptote actually never touches. It just looks like it's touching. And I know it is technically touching according to how I drew it, but it's technically not because if you go back to this table and if you keep scrolling up, if you notice, these numbers just keep getting smaller and then it turns to scientific notation. That still means that it is not touching. So it technically never touches. Okay, so now we're going to move and oh wait, I got to do the y-intercept. Well, that one's really easy. The y-intercept's where it's crossing the y-axis and it's crossing at 0, 1. Okay, so moving to my next example. If you need to use the graph, you would clear it out. Alpha y equals 1/4. Oh, and they put theirs in parentheses, so I better put parentheses to the x. Okay, now I know already that this is decay, but if you need to look at the graph, the way you figure out, I knew it was decay because this is less than 1/4, less than 1. But if you notice, your graph is now going down. If your graph is going down, that means decay. Okay, so then I'm going to go to the table and I'm going to get some points that I can plot. I cannot plot up to 16, so I'm going to do -1, 4. I'm going to do 0, 1. I'm going to do 1, and that is 0.25. And then 1 and 2 and 1/16 is going to be really hard to plot. So I'm just going to stick with those 3 points because I know I can do them. Okay, so I'm going to plot my points. -1 and 4. 0 and 1. And then 1 and 0.25. So I can see that my graph's going to come in something like that. So I've already looked at it, so I know it's going to go something like this. And it's going to level out. I dipped down a little low. I'm sorry. So level out right there. Okay, remember where it levels out is your asymptote. And it is leveling out right here on the y-axis. So that tells you your asymptote is y equals 0. Now, for your domain keeps going left forever, and your domain keeps going right forever. So your range is all real numbers. Your domain is all real numbers. Your range, the graph doesn't go down forever, but it does go up forever. So you're going to take y and you're going to pull the number from your asymptote, which is 0. And it is greater than 0, but never equal to because it's not touching. Your y-intercept will be, again, 0, 1. Okay, moving to my next example. If you notice this time, they've added more in. Sorry about that. They've added more in. I've got 3x minus 1. So before, I just had a number with the exponent. Well, now I have an extra number. So again, go ahead and graph it. 3 to the x, move over, minus 1. Now, I, again, already know that this is going to be growth. But if you need to graph it and look at it, you can see it's flat, 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 and then it starts shooting up. Since it's going up, that means growth. Okay, I'm going to go to the table, and we're going to get some points we can plot. Okay, let's see here. I'm going to start with -2 this time. I can do -2 and do about -0.9 is what I'm going to say. And I can do -1 and about -0.7. I can do 0, 0. I can do 1, 2. I can do 2, 8. And then it's too big to where I can't graph anymore. Okay, so now I'm going to plot what I can. -2 and then -0.9. That'd be almost -1, so I'm going to go right there. And then -1 and -0.7 would be really close, but just a little bit higher. 0, 0, 1, 2, and 2, 8. Okay, draw this in, and if you have to look at the graph to make sure you draw it right, you can. This is where it's leveling off at. Okay, my domain, again, I know is all real numbers. For these, they're going to be all real numbers unless they have a stopping spot. My asymptote, I'm going to start with that asymptote. It's crossing right here, and that is crossing at y equals 1, -1, I apologize. So for my range, I'm going to pull the y, I'm going to pull the -1. Since the graph is going up, it is greater than -1. And this time, my y-intercept is 0, 0. Okay, so we're just looking for some key features here. Okay, for the next one, y equals, we're going to do parentheses, 1/3, close parentheses, to the x plus 4. We're going to graph it. Okay, there it is. Now, if you notice, this is decreasing. It's coming down, so decay. Now, this plus 4, if you haven't noticed, especially on that -1, what that plus 4 did was move the graph up 4 places. Okay, so now that I know it's up 4 places, I'm going to go to my table, and I'm going to grab some points that I can plot. 13 is too big, so I'm going to start with -1 and 7, 0 and 5. Okay, 1 and 13/3 we'll have to see if we can do, and then I'm just going to put 2 and 37/9. I don't know yet. I don't know what those are. To figure out what they are, I'm going to do 13 divided by 3, which gives me about 4.3. Then I'm going to do 37 divided by 9, which gives me about 4.1. Okay, I'm going to go ahead and put the little repeating bar so I know that they're repeating. Now I'm going to graph these. I got -1 and 7. I've got 0 and 5. I've got 1 and about 4.3. So that's a little above a quarter of the way. And then I've got 2 and 4.1. So really close to 4. Okay, since I already graphed it and looked at it, I have an idea of what it looks like. I'm going to draw it in to match. So curving and then flattening out right here. Okay, I'm going to start by drawing my asymptote. Okay, I know my asymptote is at 4. Okay, my domain I know is all real numbers, and my range I pull from my asymptote, the 4. The graph is above 4, so I put a greater than, and my y-intercept is at 0, 5. Okay, 2 more. All right, we're going to do alpha y equals 1/4 times. Well, I'm going to pause during announcements 1 second. Okay, so sorry for pausing. So announcements are over. So back to what I was doing, 2 to the x. I'm going to graph it first to see what it's doing, which I know it's going to grow because this is greater than 1. So as you notice, it's going up. And this time, if you notice, it didn't move it up or down any. It moved it to the right. That's what the 1/4 did. It moved it to the right. So I'm going to make my table here. I'm going to go back to the table and find some points I can plot. I am going to start, let's do with -1 and 0.12, because that's really close to 0. We'll do 0 and 0.25, 1 and 0.5. We could do 2 and 1, 3 and 2. I could do 4 and 4, and I could even do 5 and 8. But then they would go too big to where I can't graph them. Okay, so I knew this was growth. Okay, we're going to do, and I know that because the graph was going up, we're going to do -1 and then 0.12, so about right there. Then we're going to do 0 and 0.25, and then 1.5, and then 2 and 1, 3, 2, 4, 4, and 5, 8. Okay, that gives me plenty to go ahead and draw this in, and I know it's flattening out like right about there. Okay, so I know that this right here is my asymptote, and that asymptote is back at 0. Okay, I know my domain is all real numbers. It's going left forever, it's going right forever. My range I pull from my asymptote, and it is greater than 0 because the graph is going up. And this time, you might want to use your table for your y-intercept. Your y-intercept is 0 and 0.25. Okay, for your last graph, back over here. So what do we think, growth or decay? So 5 parentheses, alpha y equals 1/2, close parentheses, to the x. Then I'm going to bring in -3. Okay, we're going to graph it. If you notice, mine's blinking yellow right here. Don't press the calculator when it's doing that. That means it's thinking. Okay, this is decreasing. The graph is going down. So I'm going to put decay, make me a table, go to the table. I cannot do -2, so I'm going to start at -1, 7. 0, 2, 1, and negative 0.5, because that's what I know that is. I'm going to go ahead and write 2 and negative 7/4, and I'm going to write 3 and negative 19/8. And now I'm going to come back and look. Negative 7 divided by 4 is negative 1.75. Negative 19 divided by 8, negative 2.375. Okay, I'm going to go back to the table because I don't have numbers that are the same yet. So I'm going to pull 4 and negative 43/16 and 5 and negative 91/32. Let's see what those do. Negative 43rd divided by 16. Oh, hey, look, now I'm at negative 2.6875. So now I have something with the same number. If I wanted to do negative 91 divided by 32, that'd be negative 2.84. Okay, I'm going to graph this. Negative 1 and 7, 0, 2, 1 and about a half. We're going to do 2. Oh, wait, a negative half. My bad, negative half. We're going to do 2 and negative 1.75. We're going to do 3 and negative 2.3 something. And we're going to do negative 4 and about there. And this is where you can start seeing it level off. So as you can see, the graph is going to go something like this. And this is where it starts leveling off. If you need to use the picture, use the actual graph. My asymptote is coming in at negative 3. Okay, my domain is all real numbers. My range I pull from the asymptote, and it is going above negative 3, so greater than. And my y-intercept is 0, 2. Okay, so now what I'm going to do is I'm going to cut this out like I told you. Okay, almost there. Let me grab my glue now. And how I'm going to put it in is I am going to glue half of this. And I'm going to stick it like that. And then make it a foldable. Okay, if you have any questions, please let me know. You're going to be completing the paper and you will need your calculator.